Okay. So, starting with number 3, which hypothesis involves equality? So when it's equal. So that'd be null hypothesis. So the second one, or the fourth one. Remember that the p-value is the probability of obtaining a simple statistic at least as extreme as the one that is actually observed. When computing the p-value, which hypothesis do you assume to be true?
Is that the alternative?
Well, with these things, you always assume, I guess, the null hypothesis to be true unless, or wait, I guess, when you're talking about the p-value.
Because, ouch, that's the one minus the other. Is that, no, wait. Never mind, I think I'm thinking about something else.
So the null hypothesis would be like, this is equal to blah, blah, blah. And then the alternative would be, yeah. So wait, what were you thinking?
Well, I think I was thinking about calculating a z-score, but because the null is the one that was accepted for the long time, and then the alternative is what's true now or proposed to be different.
Yeah, so they're using the alternative to see if the null is still true, kind of thing.
So we're assuming that the null hypothesis is still true, or we're assuming that.
So, yeah, let me see real quick. So, I guess when we do something, do we reject the null or do we reject the alternative?
When I was reading it, I thought it was like trying to prove the alternative is the new one. You're rejecting the null. But I could be way off.
So yeah, so I use the v-value to, or the p-value to reject or don't reject the, what is that? The null hypothesis.
Yeah.
So then it would be null, but then you use that to find a conclusion, which is it's insufficient to say like, or yeah, so you reject the null, but you use that to determine if the hypothesis or alternative was true or not. So in computing, you assume, I would say, the null hypothesis.
Okay. That's fine.
Okay. So now suppose the null hypothesis was mean equals 10. Use this information, which would represent the alternative of a two-tail test. That would be the non-equal one because it's both sides.
Yeah.
Okay. So what would be for a left-tailed? Which one are you thinking?
I'm thinking it would be greater. Hold on. So the mean would be less than the alternate?
Yeah.
So A.
Yeah. The way I think of it is always the, like, if it's left tail, the arrow should be pointing to the left or the other way around.
Okay.
Okay, so the right-tailed should just be the mean is greater than 10.
Yep.
Okay, now using this information, which relationship would result in failing to reject the null hypothesis? Do you have an idea on that one?
Probably if the p-value is less than alpha.
So from the slides, I'm pretty sure it said p-value is greater than alpha. You don't reject the null. So then that would be, so failing to reject would be greater than alpha.
Yep. Okay.
Okay. So which relationship would result in rejecting the null? It'd just be the opposite of less than. Okay. So using this information, which would be an appropriate alternative hypothesis? Which one would you say it would be?
So the average claim is greater than 1500.
Yeah. So, and the null hypothesis for the next one would just be equal to.
Yep.
Okay. Using this information, the insurance company assumes the distribution of sample means is normal. Is this a good assumption?
And this selects 40 claims, calculates the sample mean. Use insurance assumes distribution of the sample mean to be normal.
So
Is that counted as large sample size?
yeah, so with these ones, anything larger than 30 is large.
So it's a good assumption since
Yeah.
the population size, or since the size is large of the sample
Yeah.
size.
So for the next one, what theorem or law justifies our answer for the previous question?
It's the central limit. Does that have to do with distribution? I always get those mixed up.
Yeah, just the way I think of when it's talking about like central, meaning it'll be normal, and then large numbers. If you think of it when you flip a coin, you may, if you only flip it 4 times, you may get all heads or all tails. But if you flip it, say 1,000 times, it'll be about even. So you get kind of that 50-50.
Okay.
Okay. So, which of the following is a test statistic as defined in this lesson? Wouldn't it just be the X bar?
Yeah, that's what I was thinking. Because n's just a sample size.
Yeah. I think just the z-score is a calculation you do. It's not really a statistic.
Yeah, it's not. And that was a few lessons ago anyway.
Yeah. So in this, or using this information, what is the z-score associated with this test? Okay. Just let me know when you get an answer.
You're still going to do the x bar one minus the mean, right?
Yeah, you do that one, and then
Divided by the standard deviation with the square root of
number of sample size.
So I got negative 0.9.
Yeah, so it'd be 0.900 or negative 0.900 because of 3 decimal. Okay, so this next one, what is the p-value associated with the z-score? That one, you would just put it in the probability applet.
Is it the left one that is supposed to be shaded?
I think so, yeah, because it's saying in the test if it's less than.
So 0.184.
Yeah. So now, what inference would you make about the null hypothesis? So
if the p... Go ahead.
Oh yeah, I was just saying the p-value equals 0.10 or 184, and the level of significance is 0.05.
So since the p-value is greater, we don't reject it, right?
Yeah, we'd fail to reject it. So now, based off that, what is our conclusion for this problem?
We have insufficient evidence that the population mean is less than 150.
Yeah. Okay. So there are 2 types of errors that can be made forming a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
So that's type 2, right?
I think it would be type 1. Because
this is the whole like guilty, not guilty thing, right?
Yeah. So in the table, you would have on the left side, you have, let me see, is it rejecting it? Where was it? So yeah, we would have do not reject the null or reject, and then on the top is if it's the null hypothesis is true or the alternative is true. So when you reject the null, or wait, are we failing to reject or are we rejecting?
Involves rejecting the null when the null is true.
So yeah, so it'd be the bottom left of the graph. So that'd be the type 1.
Type 1.
Okay. So now a researcher decides that instead of using a level of significance of 0.05, he will use 0.01. Which of the following will be true? So now this one has to deal with the correlation of the alpha to the type 1. But what would you say it would be?
I don't know. If I was gonna guess, I'd probably say the probability of the null being true will decrease. But
Okay. So these ones, the A value equals the probability of a type 1 error. So if you decrease that, that means the type 1 error will decrease, but in turn, the probability of a type 2 will increase. So,
okay. That makes more sense.
yeah. So just the A value is type 1.
Proportional.
Yeah. Okay. So now if A equals, or alpha equals 0.05, what is the probability of committing a type 1 error? So,
isn't it just the same?
Yeah, that it should be.
And then a type 2, would that just be 1 minus that?
I
0.95?
I'd assume so, yeah.
Okay.
Oh, I missed one.
Which one did we miss?
Not sure. Oh, we missed. Which of the following is a test? Yeah, test statistic defined in this lesson. So it's not X bar. What would it be?
Let's look.
So yeah, what does S stand for? S was
P-value is a probability of attaining a test statistic such as Z.
oh. So Z is the test score.
Here, I can try it and see if it's right. Which number is that?
So that is number. Damn, I just moved it. It is. Where the frick did it go? Oh, there it is. Okay, so it's number 14. Okay.
The heck is going on with my computer? Okay. Okay, it is Z score, or the Z.
Okay. Well, sweet. Well, I guess missing one's not bad.
Yeah, that's not bad. All right, well, 10:30 next Tuesday.
Yeah, that should be a plan. Wait, how did you do on the test?
I got like 88-ish, I think.
So that's like missing 4.
I think I did some of the decimals wrong though.
Yeah, because I missed
'Cause
3.
on the to use the SPSS, it only gave me 2 decimals for the mean. Did it give you that?
I think so.
And I didn't add another one. I was confused on whether or not I should add another one or just type in what the program gave me.
Yeah.
I don't know. So I kind of think it marked me wrong because of rounding. So I don't know.
Yeah, so I wonder if we'll be able to see what like our actual questions were or not.
I know, I was thinking the same thing. I kind of hope so, because I want to see. I'm thinking about emailing her about it, but
Okay, well, sure.
anyway.
I'll see you next week.
So, yep. See you later.
See ya.